Thanks for coming, everyone. So my name is Trevor Porter. I'm a protocol engineer at Hyperlane. And today I'm going to talk to you about permissionless interoperability, what that means, and how you can use it in your hackathon project. So I guess just to set the scene, what Hyperlane is we're an abstract message passing bridge. So we allow you to send arbitrary bytes between two different blockchains. So two different smart contracts can interact with one another that live on different chains using Hyperlane. And kind of the thing that differentiates us the most from competitors kind of in the same realm is we allow you to deploy Hyperlane onto whatever chain you want. So if you want to be on a certain chain that doesn't have interoperability built into it today, you can go to our competitors and they'll say, give us hundreds of thousands of dollars and we'll deploy onto you. Or you can just go to our docs, run a script, run some infrastructure that we provide out of the box, and you get connectivity with a whole network of chains for free. So to start with some definitions, so we call ourselves a permissionless and modular interoperability layer. So permissionless can mean a lot of things. I think it's usually a marketing term, but to me, it means that you can do something without anybody else's permission, right? But some people will claim that permissionless means that anybody can propose a hard fork to a network, which is definitely true, but it's still gated on the node operators in that network in order to create a hard fork. So the idea with Hyperlane is you literally don't need to talk to us whatsoever. You can just go to our docs, you can deploy it. It's easy as that. That's why it's permissionless. Anybody can use it. And then interoperability, it can mean a lot of things to different people, but to me, it just means some kind of interaction between two different blockchains. So for us, we are an interface for sending bytes over the wire between two different chains. And you can build things on top of this, like token bridging, but fundamentally, just that communication is what interoperability is. So to set the scene why this is even important, we can look at the history of blockchains and where it's led us to today. So at the beginning, we had Bitcoin, and this is really great for payments, but it was not too great for many other things. So people got excited by the idea of what you could do with blockchains. If you look, before Ethereum existed, people had ideas like creating something similar to ENS, but that required creating an entirely new chain. I think it was called name chain or something along those lines. And you couldn't use the same security layer for building unique applications with just Bitcoin. So then Ethereum came. And that was kind of the first fragmentation or major fragmentation where now you had Bitcoin and now you had Ethereum. And Ethereum gave you the ability to create applications with the same infrastructure-based layer. But pretty quickly, the limits of Ethereum were hit. There's some serious scalability issues with just having a single blockchain like Ethereum. That also imposes some very prescriptive trade-offs on applications that are on Ethereum. So Ethereum wants everybody with a laptop to be able to run the entire chain, but that comes at the cost of people not being able to have really high throughput on Ethereum. So in 2019, around that time, there was a lot of talk about things like plasma or sharding or like all these different ideas. Some of them eventually turned out to be what we call rollups today. But we also saw the explosion of alt L1s, and people were moving to these alt L1s like Binance Smart Chain, like Avalanche, like Solana, instead of Ethereum, not necessarily because there was anything special about these blockchains, but because there was cheaper block space, and then new communities were created around this cheaper block space. And this was the first kind of step of scaling. But as you scale in the paradigm that we've chosen to today, you create more fragmentation. So to me, there are three valuable things about blockchains, and it's composability, verifiability, and censorship resistance. And as you scale and create new block space, you give up composability. So interoperability between all of these is extremely useful in order to preserve that composability. So during all of this, things like Cosmos or ecosystems like Cosmos and Polkadot pioneered app chains, which have kind of evolved into the rollup thesis today. So specialized chains that have their own block space that allow for scaling outside of just the world of Ethereum. And eventually today we're at rollups, and there are various rollup ecosystems. There's the Ethereum rollup ecosystem. There's the Celestia rollup ecosystem. There are still app chains in the Cosmos world. I don't think Solana is going anywhere. Like, there's still all of these ecosystems that are being built, new chains, new block space. And I think it's just an unavoidable future. And as these things get more complex and all these new ecosystems arise, there's no good way of interacting between all of these that is kind of one size fits all. And people are migrating to rollups. So Dapps like Zora, they recently launched a rollup. Celo, the L1, is transitioning to be a rollup. There's a lot of effort on the Ethereum side toward growing the rollup ecosystem. And there's a lot of like discourse around rollups that are using the same DA layer, so data availability layer, of having better and more trustless communication with one another. But this is still like super early stages. There's a lot of research going on there. Like, it's not a one-size-fits-all situation. So we need interoperability between rollups, between chains, regardless of what they look like today. And we can't really afford to wait for a future where there might be more trustless communication. So in comes Hyperlane. And further to set the scene, I guess just to like explicitly say like the common path of rollup to rollup interoperability today. If you're on Optimism and you want to go to Arbitrum, you pretty much need to wait 7 days to go down to L1, and then you go back to Arbitrum. And that's just unacceptable for the vast majority of use cases. So on top of this, there have been different protocols that maybe use an external verifying set to sign off on these messages between these rollups, or people who provide liquidity up front for the destination on the rollup, knowing that they can wait 7 days in order to get it in the future. But yeah, the general idea is all of these different rollups, they look so different. You might be familiar with storage proofs, which is kind of a hot topic in the Ethereum community of facilitating better rollup to rollup communication. And the way those work is a rollup will learn about the block header of another rollup. Inside that block header lives an attestation to all of the state that lives on that rollup. And if you come up with this proof to find out maybe what the storage slot is at a particular place in a contract in that storage route, you can read the state of another rollup within this rollup. But the problem with these is it's so specific to the implementation details of these rollups that it creates fragility. If one rollup creates a hard fork, what happens to that bridge? It's fragile. So what Hyperlane does is we don't want to wait for a future where there are all these different types of message passing paradigms that may be further along in research but look totally different, and we can't have them today. So how do we get this today? We separate the transport layer and the application layer. So what does that mean? It means that Hyperlane is an interface that is constant for all chains, but under the hood, the actual security that is used for these messages can change. And it can be different for different chain-to-chain connections, depending on what is seen as what the application wants, or we provide a default security model, which might be the most trustless security between two different chains. So to give an example, if I'm on Ethereum L1 and I want my application to send messages to Optimism, to Arbitrum, to Polygon, to Solana, the last thing I want to do is do the legwork of integrating with each of those, the rollups, their native token bridge. I don't want to know the interface and the implementation details of that. I don't want a massive switch case statement saying, this is my destination and this is the code that I want to run. I want to just have the exact same interface. I don't want to know the implementation details of how it gets there. I just want to know, sure, maybe this security of that message, but I don't want to know the interface into using that bridge. So what we do is we have a contract called a mailbox that lives on each chain. And this mailbox is the single interface for sending messages to other chains or receiving messages from other chains. And then applications, and this is where the term modular security comes in, applications can opt in to what security they want to use for messages that they receive. And this is super powerful because as new research comes out, you can kind of just change configuration and you get the new research, the new products, the new fancy ZK proof completely for free. But today you can launch and still be equipped to use that in the future. So like concretely, if you use Hyperlane between L1 Ethereum and Arbitrum today, like you'll be using the native token bridge, which is trustless, or the native bridge, which is trustless. And maybe if you were to go from Ethereum to Avalanche, like there isn't a great trustless interoperability solution there. So you'll use a different type of security. Other things you can do with this. So I guess to go into the details of how it works, on this destination side, well, the general idea is you call in on the origin into the mailbox's dispatch function. So that's how you send a message out from a chain. It emits that message. There's some off-chain infrastructure that you don't really need to worry about that listens for these messages and then comes up with the appropriate proofs in order to deliver these messages on the destination. And the way that they deliver this is by calling a function on the mailbox called process, and then that mailbox will call the recipient's handler. And there's a step that I missed there, which is the mailbox needs to know what kind of security that recipient requires. And the way that a recipient defines that is through this thing called an interchain security module. And all this is a view function on the recipient that returns the address of some smart contract that encoded into it has the rules of how to verify this message. And this is the step 5 right here. So you pass in 2 parameters into verify. One is metadata, and this can be anything that is specific to this interchain security module. You can imagine it as like validator signatures over a message, or maybe a proof verifying this message. It's some kind of off-chain data, and then the actual message that was sent. And the cool thing here is that you can actually tweak the security that you want depending on the contents of the message as well. So if my application is a token bridge that I've built on top of Hyperlane, and somebody is sending $10, do I really require them to have the most stringent security for that? If that security has like a monetary cost? Probably not. So like I could choose for a really low value transfer to maybe require like an M of N validator signatures over this message. But if there's $1 million going over, maybe that's where I'm willing to put a cost onto the user where they have to process a more expensive proof in order to verify that this is correct. And like I mentioned, this is future-proof. So as new things come out, you can really easily just change out the transport layer under the hood without having to make any changes to your application. So yeah, this all kind of leads up to our special sauce, which is permissionless deployment. So in a world which I think we're seeing, where there are countless rollup as a service companies, a bunch of new rollups being created each day, new chains, whether in the Cosmos ecosystem or elsewhere, there's just this explosion of chains that's occurring in this last year. Like speaking to so many people here, like there are a lot of new chains being created as well. And there's this problem of like when you create a new chain, it's this entirely isolated ecosystem. And the first question that clients of rollup as a service companies ask is, how do I tap into the rest of the ecosystem? And if you are, let's say, an Ethereum L2, you get a lot of that through the native bridge. But if you're a Celestia L2, because Celestia is just a data availability layer, they don't have any kind of smart contracts on the L1, you don't really get any benefit of that native token bridge to bring in liquidity into your chain. So what Hyperlane provides is just go to our docs, you can do it. If there's a chain that you guys want to deploy Hyperlane onto during this hackathon, like it's as simple as just going to our docs, running some scripts, and then running some infrastructure. I've talked with many teams who have asked like our competitors to go onto their chain, and yeah, the answer is pay us money. And I think that's just not quite in the ethos of crypto. Like if you look at Uniswap, for example, the reason why it got so big and why it's to this day like still pointed to as a great example of what DeFi is and can be for everything, It's the permissionless nature of it. It's the fact that I could just go to the Uniswap v2 factory, call a function, and create a new pool. So unlocking the long tail of assets and the long tail of chains, I think is going to be of like extreme importance to this this industry as we lean heavier into rollups. So just to talk a little bit about things that you can play with and build on top of Hyperlane. So it's all fine and dandy. Like, let's say you're a new chain, you roll up, you deploy Hyperlane onto your chain. What you get out of the box is bytes over the wire. But what can you do with bytes over the wire? You can build applications on top of that, and really anything that you want. But an example of that is just basic token bridging. We have our own twist on token bridging called warp routes. And instead of like a classic token bridge, so a token bridge, when I say this, it's like a lock and mint kind of thing where on the origin side, let's say I have a token, I send it into some contract where it's escrowed. Some message is sent to the destination chain, and then a new token is minted and given to me. And that new token we generally call a synthetic token because it relates to the existence of a remote chain's real canonical token. In a classic token bridge, they usually have a security model that they impose on the entire bridge. And it kind of turns into this honeypot of like, this is like a specific one-size-fits-all security model that is being forced onto this token bridge. Whereas with warp routes, it works for permissionlessly deployed chains, and it allows the deployer of a warp route, so the deployer of this bridge token, to specify what security they want for it. So it's kind of like a tool in order to bring tokens onto your chain in the terms that you want to. So we have 3 different classes of these. So there's a native warp route. And what this means is, let's say you're on L1 Ethereum and you have ETH. ETH is the native token. So there is a smart contract called a native warp route in which you just send your ETH in there, you call a function, your native ETH is escrowed in there. And then that's where the on-chain or the message is sent to the destination chain, where then a synthetic token is minted. We have the collateral version, which is for an existing token that isn't the native token. Similar idea, escrowed and then mint. And these are particularly useful for chains. Let's say it's a rollup that maybe wants like AVAX on its chain. So you have a bridge that is lock and mint in structure that you get to define the security parameters for, and you get to deploy yourself. And so we offer scripts to deploy these things really easily. We offer a UI that you can customize to look however you want as well. That's what that screenshot is there. And it all just kind of works end to end out of the box. Yeah, great question. So yeah, Circle supports native transferring between 2 different chains. I think today it's Ethereum and Arbitrum, or Avalanche and Arbitrum as well. Ethereum, Avalanche, and Arbitrum. So those 3. And yeah, this is great. I think you should use this instead of warp routes because Circle is attesting to like the validity of all of these tokens, and they've like blessed these tokens on all 3 of these chains. And I think you'll actually see like a continuation of this for like the very popular fathead chains. These kinds of tokens will have canonical representations on those chains. But for the long tail of chains, Circle is not going to support some random rollup out of the box because they have no incentive to. So that's where Hyperlane warp routes would come into play. And that kind of also like plays into our eyes being set on permissionless deployment for these long tail of chains. So that in that scenario, the canonical USDC token on Arbitrum, you could bridge that to like my rollup if you wanted. And in that scenario, it would be the USDC would be turned into a collateral warp route on Arbitrum, and then it would be sent over to my rollup, and then it would be minted to me as a synthetic token. So I think these things aren't mutually exclusive, and like I think the trend of long tail chains having canonical representations for these kinds of centralized stablecoins will continue as well. Yeah, exactly. Yeah. So that's it. If it's not the canonical one, like in our jargon, and some people use it differently, that's a synthetic token. So it's like pegged to the value of a token that exists on a remote chain. Cool. So a couple other things that you can build or play with that we've built for you that are really cool primitives. Of these things called Interchain Accounts and Interchain Queries. So this is borrowing from the Cosmos ecosystem, where they have these same primitives. But for context, the Cosmos ecosystem, they have this like really robust way of communicating between chains called IDC. But the implementations today are very specific to the Cosmos ecosystem. So it only really works for these chains that have the same kind of consensus mechanism. Whereas Hyperlane, it works anywhere in any kind of execution environment. So we can look at kind of the cool primitives that they've played with and built already, and then bring it to the rest of the ecosystem. And what Interchain Accounts are is a smart contract wallet that lives on remote chains that is controlled by a smart contract on an origin chain. So an example of this could be like a DAO, for instance, that lives on Ethereum. They can control a smart contract wallet on some remote chain. They can own contracts through that. They can call contracts through that. They can own tokens. They can own Ethereum, like native tokens. They can do anything. And another cool thing about this, there's this word called like counterfactual addresses, which are addresses that you can generate and know what that address is without actually creating it or requiring any action from the owner. So an example of this is like, if you're familiar with Create2, if you know the bytecode hash and then a salt in order to deploy this contract, you know that it'll exist at a particular address. And then the importance here is then, like the Uniswap DAO, if they wanted to use interchain accounts, they don't need a DAO vote in order to create one of these. They can just know that they own this theoretical address that exists on a remote chain without any kind of action on their part. And then there's this thing called Interchain Queries, which allows a smart contract on one chain to query some state on a remote chain and then get it sent back to it. So I can, maybe I'm on my rollup and I really want like chain link price feeds. I can use Interchain Queries to query the current chain link price feed that lives on Ethereum. And then I get back a call into one of my functions with that value. Yeah, I'll leave it here for any kind of questions. I was thinking I could do a live demo, but I don't have the time. But yeah, if I were to ask you guys to have one takeaway from this, it would be that Hyperlane is the only permissionless interoperability project. And yeah, we're excited to kind of hear you guys' feedback about it if you're deploying to new chains. Or if you have any like cool ideas around modular security that you guys are going to play with. I think there are just so many things that, yeah, I would be doing during this hackathon on Hyperlane. So if you have any like ideas that you want feedback on, feel free to let me know. Happy to take any questions if you guys have them. Oh, we have a booth downstairs as well. Sit.
Yeah, a quick question related to like bridging, yeah, that you've called warprods, basically. Yeah, like what's your take on like bridging data? I mean, not just related to tokens and NFTs, but everything else. Like, how do you do everything else?
Yeah, so Hyperlane just allows you to send anything over the wire. So you can send, if there's like KYC data on one chain or something like that, you can send that to a remote chain. You could even have applications that are natively multi-chain, meaning that their state kind of exists on these two different chains or multiple different chains, kind of like a distributed system type deal. And yeah, I think there are just so many interesting things that you can do on top of that. You can have like multi-chain liquidity layers. So you could have some kind of protocol where you have pools on different chains, and when you want to go from token X on chain A to token Y on chain B, you use an abstract message passing bridge to first do that swap, then send the message over to the destination, do another swap, things like that. So I think there are so many things that are like super underexplored. I will say, like, once you add asynchrony into building these applications, so like when you just write a normal smart contract today, like you have a lock on everything that's happening on that blockchain. And that means that you can interact with all these smart contracts and know that there is synchronicity in all of these interactions you have. And if it reverts, that no state changes will occur. Once you add asynchrony in here, things get a bit harder. So it does require like a little bit of careful design and what these messages do. And maybe you'll want timeouts for these messages and like a failsafe. But yeah, there are a lot of cool things you can do with it.
Yeah, thank you. That answers the question, do anything.
Yeah, basically.
Mm-hmm. Mm-hmm.
Give a round of applause for Trevor.
Thank you.